All right. So, as we know that there are many translations possible for a given foreign sentence, right. And then there is a set of references also available for the same sentence. For the same English sentence, I should be able to construct a similar set of English sentences. So, I should be able to generate more English sentences which mean the same thing, correct. And then when you give those hypothesis to a human person, he immediately looks at it and then say, okay, this particular one is good, let us use that as the right translation for the foreign sentence that we have seen. Okay. So, how does he do that? So, is he really looking at the sentence word by word or in phrases, or he looks at the entire sentence as a whole and then make sure that what he is seeing is the right translation. So, what is the mechanism by which he really translates, and that is what we want to use to automate this. So, one way is a very simple this is a very simple assumption that we can do. Look at every word from the hypothesis and then compare it with the reference sentence one by one, and if they match exactly the way in which the reference sentence is written, then you pass that. Otherwise, say that okay, it has got some errors and do not pass. So, that is a very punitive way of doing it. So, we should be able to pass sentences that are at least 75% right or 80% right, something like that. Can we use a mechanism of what we had studied earlier, right, in terms of breaking the sentence into unigrams, bigrams and trigrams or fourgrams, and then compare every word, every n-gram with the reference sentence and then start providing a score, as I mentioned earlier during the introduction of this, right. So, here what I am going to be doing is I am going to be providing two candidate sentence, okay, and then one reference sentence. Okay. One thing which I forgot to mention, the idea that I am talking about is coming from this paper written by Papiniani and others. Okay. So, this is the one which is the seminal paper that you want to read as well. If you want to really understand what went through when they were developing the standard. I am going to be doing some portions of the paper in this particular session as well. Okay. So, this came I guess in the year 2001 or 2, I am not sure. Okay. So, what they have done is they have used a very simple idea of comparing the n-grams. Okay. And then as and when they started doing that, they also found that there are issues with respect to short sentence. For example, if I just use these 4 words as my candidate sentence, and then this is my reference here which also has those 4 words, and this is the sentence that came out of the translation system. So, how do you validate this? So, you would like to say that this sentence is 100% right. Okay. So, in a way you can score it, but it is inadequate in a sense that the reference words are longer, rather the reference sentence is longer than the candidate one. So, if I just provide you this particular word alone, then it will pass. It is not the right sentence, it is just a single word, right. So, we do not want to give 100% rating to that. Okay. So, these rules start coming out as in when they started building this standard, and then we see how they really added those rules into the system to finally create a good standard. Okay. So, as we look at the sentence, right, we start looking at that in terms of n-grams as we mentioned earlier, and then when we see more number of n-grams are found in the reference sentence as well, then we can say that okay, this candidate has passed with certain score, let us say about 80% or 75% and things like that, or it's only about 10%. Okay, so this is one way, just to find out how many unigrams are there, and then how do you find this set of these, right. From the set of these two, when you do the intersection, you know the common words that are coming out of this, right. And then if I count the number of words that are found due to the intersection, and then if it is equal to the same number as the reference sentence, you have a 100% match. If you do not have the numbers as in the reference sentence, then the percentage starts coming down slowly from the 100% to maybe 5%, 10%, depending on how many words are aligned to the reference sentence. Okay. So, that is one very simple way of looking at that. Okay. So, that is where we are going to be looking at the n-grams and see how those matching of n-grams really help us in terms of creating this standard. Okay. So, as I mentioned, compare the number of n-grams in the candidate and in the reference translation. Okay, so, that is one way. And then penalized model that are producing many words of the same type. For example, in this case, if my system creates something like this, for example, I have a unigram model, okay, and then it looks at the language model and then see, okay, I have seen guide or what is the next word, and then based on the frequency it starts giving me the same thing. So, for example, this word is found very often. So, it is possible that we can have a sentence of this type. Okay. We know that it is not the right sentence, but the candidate sentence could come from the translation system, may have one of these. Okay. And then we want to have a reference system as cat is on the mat. So, the is found in this, okay, and it matched with all the 7 words that are there in the reference system in terms of numbers. Okay. So, we can say that when you match this, the is found and then all 7 words that I have seen in terms of the count of reference. So, my unigram count could be 7 by 7. We know that it is wrong, correct. So, there are only 2 places where this is connected to the reference, one here and one here. So, when you want to use a good precision mechanism, what you do is you just count how many times those words are available in the reference systems, okay. And then use that number and then find out how many words that your hypothesis contain, and then use that as the denominator, and then you get a ratio of this type. Okay. So, this is the first way of looking at it. So, this is called the modified n-gram precision. Instead of scoring it 7 by 7 using the normal n-gram, we say that we are going to be looking at how many words are aligned or found in the reference system by looking at the candidate sentence, and then use that for your precision computation. Okay. So, in this case, you look, I am just taking a very small short sentence for us, and then we will go to the long sentence later. So, I am going to be looking at the bigram. So, when you want to do the bigram, so this is what the bigram is, right. So, we want to be looking at whether we have the and the happening in this, we do not find any of those. So, the modified bigram precision will give you 0, even though you have many bigrams available with respect to the count in the candidate sentence, and then there is no bigram that matches with the reference bigram that you have, correct. So, that means your modified precision, bigram precision is 0. If you go to the trigram, again in the same fashion you can look at it. When you do not have the bigram, there is no point in doing the other one, but still for the sake of understanding I am doing this. Okay. So, in this case again there is no trigram available. So, your score is going to be 0. That means this candidate will get a score of 0. Okay. Whereas, when you use the unigram you get the score of 2 by 7. Okay. Now, look at the rule that we have. We count the number of times a word occurs in any single reference translation. Okay. And then use the reference count to clip that. See, for example, you have 7 here and what you get is 2. So, now the sentence instead of 7 it becomes 2. So, you are going to be clipping that, which says you go and then find out how many references you find in the reference sentence for the candidate words that you have here, and then use that as your count. We call it as clipping the count. Okay. And then use the total number of words in the candidate sentence. Now, let us go to the long one here. So, I am going to be looking at the modified unigram precision of the second candidate, okay, as we had done earlier. So, what you do is you just start looking at the words that are matching. Okay. So, in this case you will find there are 8 words that are matched, okay, from the candidate to the reference. Okay. And then how many words you have in this? There are about 14 words, and then use your modified precision as 8 by 14. So, if you look at the bigram precision for candidate 1, you will find 8 bigrams that are matching the reference sentence, and then there will be 17 bigram counts in the candidate sentence, and the precision becomes 8 by 17. Okay. So, this is how you calculate the modified n-gram precision. All right. So, by combining all of this, you remember we mentioned earlier that it is not just enough to use unigram precision, you also have to look at the other n-gram precision and then combine them and provide a single score. So, why is that important to combine bigram and trigram or 4-gram? It is enough if you do with unigram. So, when you do that with unigram, what is going to happen is you are actually doing it for adequacy. Right. So, we do not know whether the sentence is truly syntactically right or not. We only just compare the number of words that are matching with the reference sentence. Right. So, we will never be able to figure out the fluency part. Okay. With unigram, we will never be able to find the fluency part, because the context is not attached to that, okay, because it is only looking at one word at a time. You remember when you add more and more words in the n-gram, even during the language modeling part, also in the neural net learning of skipgram based model and CBOW based model, when you provide more context, we would be able to fluency of that language, right. So, when we use unigram, we say that it is not good enough, it probably gives you the adequate, it will tell you whether the translation is adequate or not, but not beyond that. So, that is the reason why we are now combining unigram, bigram, trigram and 4 grams. So, in the case of blue, 4 grams are used, all 4 grams are used in the blue model. Okay. So, it is not just enough to compute all the modified precisions for all the 4 grams. We need to look at whether the sentences are short or long. If it is long, I think there is already some penalty provided. Okay, it will be you will not find many patterns that are matching or words that are matching. So, there is already an inbuilt penalty for the long candidate sentences. For short sentences, as I mentioned earlier, there is no penalty. It would provide a good precision, or rather it would provide a good adequate translation score. So, we need to penalize the sentences that are pretty short as well. So, what blue does is it provides a brevity penalty called BP, which is introduced when the length of the candidate sentence is less than or equal to the reference sentence. We provide an exponential decay for that. Okay. So, actually when you start looking at the translation score from sentence to sentence, okay, using some small application, you will see that the unigram precision will be around here, and then your bigram would be here, trigram would be here. So, if you add more and more sentences, you will see that it is decaying in this fashion exponentially, okay, as we add more number of n there. Okay. So, to adequately compensate for small sentences, which would give you a very high score, right. So, this kind of exponential decay is studied and incorporated as part of the brevity penalty for all the score that we are going to be computing here. Okay. And it uses an expression BP equal to 1 if a candidate sentence is longer than reference sentence. If it is smaller, then we use the exponential given here. Okay. So, R is the effective length of the reference corpus and C is the length of the candidate sentence here, right. So, again as I mentioned earlier, this we are talking about the paper written by Papineni and others. Okay. Okay, so, now finally, you need to combine all the n gram precision and the brevity penalty to get a blue score. So, when you compute the brevity penalty and then compute all the n gram or the modified n gram, sum all of them, okay, and then finally get the score. So, when you do that, we need to know what this as well. Okay. So, this is the modified precision score for the entire corpus. So, one thing we need to understand is blue works not with one sentence, it works with the combination of several reference statements. Okay. So, usually blue is not applied to one translation, rather one sentence translation. So, you need to have a lot of reference translation available for you to really compute this score. So, that is the reason we have this. So, in this case what we do is for every candidate sentence that we find, we count the number of clips as we had done earlier and then sum them up using the n gram if it is 1 gram, unigram, bigram and so on, and then I use this in the denominator to find a score. So, this is done for the entire combination of candidate and reference translated reference or the gold standard that we have. Okay. So, this clear. So, the way we are combining BLEU get the brevity penalty, and then for all the sentences, candidate sentences, you find the clip value one by one and sum them up, and then you also know how many candidate sentence that you have, and then count the number of words in all the sentences, and finally create one PN. Okay. So, this involves both the reference counts as well as the total number of counts in the candidate sentence.